This short video demonstrates the difference between manual mode and automatic mode for a process loop controller as we attempt to control the speed of an electric motor. Right now, you see the loop controller in automatic mode. We can tell that from the green telltale LED by the auto manual button. We are maintaining a set point very close to 50%, 50.08 in this case. And what I'm going to do is show you how this responds to a load placed on the motor, both in automatic mode and in manual mode on the controller. First, I'm going to switch to manual mode. I'm going to switch to manual here, and when I switch to manual, I'm going to reach over with my finger and touch the shaft of the motor. What this is going to do is slow down the motor mechanically. We're going to see the results of that looking at the bar graph on the face of the controller. We're going to see the process variable bar graph as well as the set point go down as I physically load the motor. So watch. You can see those bar graphs drop. The reason both bar graphs are dropping is because this controller has a feature called set point tracking. When in manual mode, it takes whatever the process variable value is and makes that the set point value as well, so that when you switch back to automatic mode, these two start in a condition of equality with zero error. So once again, to demonstrate, I load down the motor and you see the process variable bar graph and the set point bar graph go down. You see no response whatsoever out of the output or valve bar graph because the controller is in manual mode. It's not trying to correct for anything. Now I'm going to switch into automatic mode. So I press the auto manual button. At this point, it's going to try to maintain a set point of very nearly 51%. Watch the difference in response on the bar graphs here as I slow the motor down. I slow it down. First, you see that the set point bar graph did not change. It's now fixed. That's where we want the speed to be at. You also notice when I press the motor shaft, the process variable bar graph dipped down, but not nearly as much as it did last time in manual mode. Furthermore, you'll notice that every time the process variable bar graph dips down as I touch the motor shaft, the output bar graph rises. This is the response of the controller in automatic mode when it sees the motor slowing down. It sees it slowing down below set point and it says, hey, I'm going to throw more power to the motor to pick the speed back up and to correct for that load. So once again, I slow down the motor. You see the process variable bar graph dip down. You see the output bar graph rise, but not nearly as much as what happened when it was in manual mode. In manual, I load the motor down. The speed drops quite a bit, and no corrective action is taken whatsoever by the controller because it is in manual mode. In automatic, however, I slow the motor down, and the controller fights that change. It raises the output value to try to correct for that slowdown in speed and to attempt to bring back to set point.